Graph both equations on the same graph and estimate the simultaneous solution. Now, if I'm being asked to graph the linear equations, remember I can use any of the three methods that I've learned from the previous chapter. Remember that you can graph the equations by creating a table of ordered pairs. You can graph by using the slope and y-intercept method, or you can graph by using the intercepts method. So choose any of the three to help you graph, and just make sure that your graph is accurate. So I'm just going to choose the intercepts method. And recall, with the intercepts method, we will take on our linear equation and we let one of the variables be 0 in that linear equation, and we try to solve for the other variable. So in 2x minus y equals 6, we are going to let x equal 0. So if I want to solve for y, I'll have negative y equals 6. And keeping in mind what it means to have a negative in front of the y, it's like having a negative 1, which means if you divide both sides by negative 1, you will have your y value, which is negative 6. So this would leave me with an ordered pair, 0 for x and negative 6 for y. So that's one of the ordered pairs for that line. The next step in the intercepts method, we will let the other variable be 0. And so when we plug it into our equation, 2x minus, instead of y, we'll say 0 equals 6. We'll try to solve for x now. So 2x equals 6. In order to solve for x, we'll divide both sides by 2. So I will get x equals 6 divided by 2 is 3. So that will leave me with the ordered pair, 3 for x and 0 for y. So these are the intercepts of the linear equation 2x minus y equals 6. So I'll keep this in mind while plotting. Maybe before that I might want to show some work on how I can find the intercepts for x plus 3y equals 10. So I'll do that next. So from 2x minus y equals 6, we have the intercepts 0, negative 6. That's the y-intercept. And the x-intercept is 3, 0. I will now do the same thing for x plus 3y equals 10. Again, with the intercepts method. I will let the x be 0 and plug that into my equation. So that will leave me with 0 plus 3y equals 10, which leaves me with 3y equals 10. And dividing both sides by 3 will leave me with y equals 10 thirds. So I will get my ordered pair. X will be 0 and y is 10 thirds. And I notice that it's a fraction, and when we get ready to graph, I'll tell you how we can best deal with that. So before we start graphing, we still need to find the other intercept. So I'll let y equals 0 for the other one. That means I'll have the equation x plus 3 times 0 equals 10. So that will leave me with 3 times 0 is 0, so that actually gets x equals 10. So the ordered pair I'll be looking at, let's see, our x comes first, and our y comes second, so 10 comma 0. So we actually have our ordered pairs. The intercepts would be 0 comma 10 thirds and 10 comma 0 for the linear equation x plus 3y equals 10. So now we're ready to graph. So let's plot the intercepts to our first equation on the axes. So 0, negative 6 would start at the origin and we would count 6 units down. So we should get an ordered pair right about here. And 3 comma 0 will start at the origin and we actually count 3 units to the right. So our ordered pair should be about right here. So if we connect these intercepts with a straight line, we will have our linear equation 2x minus y equals 6 graphed. I'll also want to plot the intercepts for the second equation. So I'm going to go with 10 comma 0 first. That means we'll start at the origin and move 10 units to the right. So we should land about here. And paying attention to my second value, our second intercept, I look at 10 thirds and I notice it's a fraction, so it's kind of hard to graph it right away unless I consider the mixed number form of it. So 0 comma 10 thirds, that's equivalent to saying 0 comma 3 and 1 third. And the reason how I'm getting the 3 and 1 third, remember from your previous math classes, if you take an improper fraction and you divide the denominator into the numerator, 3 goes into 10 3 times. 3 times 3 is 9. We subtract 9 to get a remainder of 1. We get the equivalent mixed number, 3 and 1 thirds. So I just want to remind you how to do that. So if I plot 0, 3 and 1 thirds, that means I'll start at the origin. I should be counting up 3, and then I'm going to land in the middle of these between 3 and 4, about 1/3 of the way over. So in order to do that, I'll try my very hardest. Should land about here. So now I'm ready to connect my intercepts. Do that with a straight line. As best as I can. And you'll notice that we're looking for the point that is common to both of the graphs. So the way I'm looking at it right now is I'm seeing it where the intersection is. So that's estimated to be about, let's see, that's the solution. And if I can count where that lands, if I count from the origin, I'm moving 4 to the right and up 2 to get there. So let me label that. 4 comma 2. So that is the ordered pair that is common to both of the equations. So we have now solved our system by graphing, and the solution is 4 comma 2.